Let's start simple. Imagine pointing your finger at a tiny spot, adjusting until it's perfect. That's what a servo is. It moves to an exact position and holds it. Unlike a fan motor that just spins, a servo is all about precision and control. You can tell it exactly where to go, how fast, and how quickly to get there. It listens to detailed instructions: position, speed, acceleration. What makes it special? It's a closed-loop system, always checking if it's reached its goal and correcting itself if not. This constant feedback is the secret to its accuracy. Think of a dancer making tiny adjustments to hold a perfect pose. Servos do the same, but with machines. That's why they're everywhere. In robots building cars, cameras focusing on faces, and machines packaging food. They're the hidden muscles of the modern world, performing tasks with a level of precision humans can't easily repeat. Quiet, reliable, and incredibly accurate, servos bring mechanical grace to everyday technology. They may be small, but their impact is huge. Next, let's see what's inside these smart machines. Scene transition. Inside every servo machine is a team: a motor, a position sensor, and a controller. The motor is the muscle, moving parts as needed. But muscle alone isn't enough. It needs guidance. That's where the position sensor comes in, constantly tracking the motor's position, like eyes for the machine. The sensor provides feedback, telling the controller exactly where things are. The controller is the brain, receiving commands and comparing them to the sensor's feedback. If the motor isn't where it should be, the controller tells it to adjust. This loop, command, sense, correct, creates a system that moves with intelligence and precision. The motor gives power, the sensor gives awareness, and the controller makes decisions. Together, they form a servo mechanism, a self-contained system built for accuracy. It's not just about movement, it's about smart, adaptive movement. That's the beauty at the heart of every servo machine. Scene transition. Not all servo motors are the same. Each is built for a specific job. DC servo motors are common in small devices, like remote-controlled cars. AC servo motors are the heavy lifters, powering industrial robots and CNC machines. Permanent magnet synchronous motors are efficient marathon runners, perfect for systems that run all day, like conveyor belts. Brushless DC motors last longer and need less maintenance. Think of your computer's hard drive. Positional servos move to a set angle and hold it. Continuous rotation servos spin all the way around, but with controlled speed. Linear servos move in a straight line instead of rotating. Each type has a unique talent: precision, power, efficiency, or endurance. The right servo motor makes all the difference in performance. That's why they're found in everything from toys to factories. Next, let's see how we actually give these motors their orders. Scene transition. How do we command a servo? With electrical pulses, a secret code it understands. The width of each pulse tells the servo where to go: short for one end, long for the other, medium for the middle. By adjusting pulse width, we control the angle precisely. These pulses are sent rapidly, about 50 times per second, keeping the servo locked in position. If something tries to move it, the servo pushes back, holding its place. This active resistance is why servos feel strong and reliable. Computers and microcontrollers generate these pulses, making complex movements possible in robotics and automation. It's a simple language, but it lets us bring digital designs to life. The servo listens, responds, and adapts in real time. That's how we turn electronic instructions into precise physical action. This partnership between code and machine powers modern technology. Now let's see why these small machines matter so much. Scene transition. Servo machines are everywhere, often hidden but essential. In robotics, they're the joints that give arms human-like precision. In cameras, they focus lenses instantly for sharp photos. In factories, they fill, seal, and label packages with perfect consistency. Solar panels use servos to track the sun, boosting energy efficiency. CNC machines cut metal for cars and planes with microscopic accuracy. Textile machines weave intricate patterns thanks to servo control. Servos bring speed, quality, and reliability to modern production. They're the bridge between digital commands and real-world action. High efficiency, precise control, and adaptability make them vital. They're a foundation of automation, manufacturing, and even our daily gadgets. Understanding servos means understanding the quiet engineering shaping our world. That's the power of the servo machine.